Hello everyone, my name is Abhishek Pandey and today I am going to describe our graph database. So what is graph database? Graph database is a special kind of database that focuses on how things are connected to each other. Regular database stores in tables like rows and columns in a spreadsheet. But a graph database stores data very differently. It stores things and connection between those things. For example, let's say Alice and Bob. Let's take the example of Alice and Bob. If we know the relations are like knows, lives in, and brought, so Alice knows Bob's can be shown as a connection between Alice and Bob. So this is simple example of a graph database. Now graph database has three main parts. They are nodes, which are the things, which are the objects or items. The following examples of it are a person, a city, a product. You can think of nodes as dots in graphical sense. Now relationship are the connection. It shows how these nodes are connected. Likewise, said before, its example are nodes, leavings. Now there are extra details to describe nodes or objects. They are known as attributes or properties. Both nodes and relationship can have properties which are like small pieces of information. Like a person node can have properties like name, which describe Alice, uh, uh, and age, and relationship also can have different properties. For example, since when, like since 2020, since 2021. So properties are like labels or descriptions. So let's talk about how is it different from relational database system. Now relational database system stores data in tables which have rows and columns. It works like a spreadsheet in Excel. While graph database store data as nodes and relationship, it focuses on connection between these data. Now, how data is organized? In relational database, data is split into many tables, which are connected using keys, like foreign keys, primary keys, etc. You often need to join tables to get full information of how the database is working. In graph database, data is stored as network, and connection are the part of the database. So there is no need for complex joins and keys. Relational database In relational database, relationship are indirect. So you must use joins to connect data. This can become very slow and clunky when data is large and there is very deep relationship between these entities. While graph database relationship are direct and built-in, which are very fast for even large data samples. While relation database is fast for simple queries and structured data, it is slower for complex relationship model. While graph database is built for this relationship heavy queries. Relational database provide a fixed structure where entities and properties are uh, structured in tables, rows and column. While graph database has flexible structure where it is easy to add new types of nodes or relationship. Now, how this graph database works? Its example, its use case will be presented by my friend Avinav Khan.
Thank you, Abhishek. I'm Avinav Karn here to present advantages of graph model. The first advantage that graph model provides over relational database models is speed. Now, when we think about how do we search data in a relational database, we normally query them, and indirectly the rows are searched individually in a database. But in the context of graph databases, we traverse the databases via a certain path. Now, how does this help us? In certain real life examples, such as social media sites, we have to find certain data, such as friends of friends or related things. Relational databases does not provide an implicit mechanism for doing this, but graph model, data model is superior in terms of finding relations as well as multi-hop traversals. Next up is flexibility. When we try to update a relational database schema on the go, such as when the production server is already active, it's difficult. We have to maintain a certain amount of downtime, then only we can upgrade it. But in the case of graph databases, that everything can be changed on the go. The schema develops as the data number of data points grow. Next up is visualization. Graph data is inherently the kind of data that is present in nature. So visualizing such data in graph model is very much simpler compared to the relational databases. And then finally, relationship centric. In relational databases, entities are generally in rows, forms, and several of their attributes are presented in columns. But what about the relationship between several different entities? It's not inherently explicit, but graph model eliminates this. So every single relation is highlighted. Now I will present some typical use cases of graph databases. The first and foremost is social networks. Many of us have used LinkedIn's, and we must have noticed that there is a small information which gives us about the number of degrees by which we are connected to anyone else on the platform. Generally, our directly friends are connected as first degree of freedom. Our friends of friends are connected by second degrees of freedom, and so on. But keeping track of these is difficult in relational database models. Graph database becomes superior in such cases. The next stop is fraud detection. For explaining fraud detection, I would like to show you an example. Let's say we have two tables, accounts and transactions. Now, uh, how does fraud detection take place? Generally, if we send our money to someone and it traverses a certain number of nodes, such as I give my money to my friend, he passes it to someone else, and so on, and until finally that amount of money arrives to me, it is difficult to track in relational databases. For instance, I have to track every single transaction that has occurred from every single account. But in case of graph databases, that is not the case. Say, for example, A has sent some amount of money to B, then B sends some amount of money to C, and finally C sends the same amount of money back to A. Now we can see that the net result for A is essentially zero, and there is a cycle formed over here. These cycles are what help us to detect frauds in our systems. This graphical databases have found huge use cases in such types of financial fraud detection mechanisms. Now, moving forward with the presentation, I would like to call Ridan Bhattrai.
Thank you, Abhinav. Now I would like to talk about some popular services for the mm, popular service providers that provide service for using Graph database. The most popular one is Neo4j, who is the industrial leader for graph database architectures. Neo4j also has a proprietary query language called Cypher Query Language. We will see more about that on later. The second service provider is AWS Neptune, also known as Amazon Neptune. Graph database is one of the many services provided through AWS or Amazon Web Service. AWS uses graph database that supports both Gremlin, which is a standard used by Apache, and SparkQL, which is the standard used by W3C. Uh, the next famous database vendor is OrangoDB, which is a multimodal database that supports graph database and document databases like MongoDB. Also, key value database, which store the data in key value pairs like JSON object. One of the other database vendors is Tiger Graph, and the second last one I am going to talk about is Janus Graph, which is an open source distributed graph database. Finally, there is also another service provider called Memograph, which is a graph database that runs entirely in your RAM, so that it makes the transaction even faster than other traditional databases. Now, moving on to the implementation challenges, uh, there are some certain limiting factors that limit how quickly we can use graph database, or how quickly the graph databases are implemented in our day-to-day lives. First major hurdle is a query language learning curve. Transitioning from normal SQL to Cypher or Gremlin or other languages like SparkQL takes new mental model and time and effort for training or producing that manpower, which is why adoption of graph database isn't progressing as rapidly. The second challenge is, I call it as data modeling, which also is related to practice. Since people are so used to normal SQL, they don't have fundamental mindset or skills to identify correct nodes and edges, or how to link them. That's why it is also proving a challenge for adoption of graph databases. The third one is performance tuning, and I think the ecosystem is in a similar boat, because SQL has a history of tools and manpower and community that is driving it forward, while graph database is in its premature state, which is why the ecosystem hasn't developed very much. Now, coming back to the topic of Cypher QL, uh, which is a proprietary kind of uh, query language that is employed by Neo4j, the leader of graph database systems in current world. It uses ASCII art like syntax that makes relationship pattern visually intuitive. For example, it gives the syntax like Alex, and there is some kind of ASCII art which includes the word like, and there is another kind of entity called Bob. In this way, it's very visually clear and intuitive for understanding the relationship between nodes. While Gremlin is a more rigid structure, but is employed by many more vendors. Now, I would also like to mention SparkQL, which is a which is the standard for W3C. It is useful for RDF data, or resource description framework data, that that is used mostly in knowledge databases where there is not a rigid structure. So it's like a knowledge library which is expands like a web without a rigid structure. Such kind of data is more efficiently queried and processed by SparkQL, which is the sole reason why the World Wide Web also considers SparkQL mm, most its most viable tool for maintaining its databases. That is all for our presentation. Thank you.